Good morning everybody and welcome to our show Technologies for Dummies, featuring a new documentary on photovoltaic panels.
As we all know, energy has become a major and worldwide challenge for the beginning of this century.
The solution to this problem is to use renewable energies such as solar energy. This energy is very abundant, however it remains barely exploited. It is therefore necessary to exploit this resource thanks to photovoltaic panels.
We must say that solar panels represent a burgeoning field. Indeed, from 2000 to 2011, the installation of solar panels in the world has evolved exponentially from about 1,500 to 70,000 installations per year. However, the effectiveness of this technique needs improvement.
Hi, Jonas. You seem confused.
Einstein, I actually don't understand all that stuff about solar panels and quantum mechanics. How is it possible that light can create current?
It's not that complicated, you know. Quantum mechanics establishes that every particle has a wave-like behavior and every wave has a particle-like behavior. For example, light is an electromagnetic radiation, but is made of tiny particles called photons. Each of these photons carries a precise amount of energy. Electrons have meanwhile a wave-like behavior, forcing them to take on values of energy only between some intervals.
I remember that they told us that there are three types of materials: metal, insulators, and semiconductors. In the metal, the last band is not completely filled. In an insulator and semiconductor, it is. And the difference between them is the gap energy.
This is correct. Now, what happens when a photon encounters a material? If, and only if, the energy of a photon is sufficient to bring an electron at a higher state of energy, it creates an electron-hole pair. In a metal, the electron and the hole will directly recombine because there is no gap between them. But in insulators and semiconductors, they will reach to the top and the bottom of their bands. Their remaining energy is converted to electrical energy, and that's why we use semiconductors in solar cells. The fraction of energy converted into electrical energy depends on the value of the gap, and it turns out that the one that maximizes this fraction is very close to the gap of silicon.
Okay, it's much clearer now.
In your previous dream, Einstein explained you all light can be converted into energy, and now she's going to explain you solar cells' behavior.
Solar cells are based on the photovoltaic effect. The solar cell behavior may be understood with a simple model. This model is constituted of
a generator that corresponds to the flow of electrons and holes, one diode and two parasitic resistors.
Now I'm talking about the diode. Pure semiconductors don't allow an electric current to flow through them, but it's possible to modify them by doping regions. There are two types of doping, P and N. To obtain an N doping, we have atoms of supervalence valence compared to the semiconductor. Conduction is assured by the extra electron. To obtain a P doping, atoms of inferior valence are introduced, and conduction is due to the displacement of positive charge. When a photon hits the photovoltaic cell, an electron-hole pair is created. What we want to do then is to apply a potential difference to the created pair in order to avoid recombination. If we bring together N and P-type semiconductors, electrons and holes close to the NP interface will migrate in the opposite zone. An electric pipe is created. Inverse polarization creates very weak current. This characteristic is typical of diodes, which only allow current to flow through one direction.
What the
So I heard you want to know more about my equation. The equation I wrote describes how the constant state of some physical system changes with time. With it, we can find energy of a quantum particle. First of all, I need something to describe the behavior and the state of a quantum particle. I call it the wave function. The density of particles probability is given by the square of the absolute value of the wave function. This density is in most cases time independent. So, as I know and you should know too, the equation of standing wave is time independent is given by, and thanks to my friends probably, we can write the sum of all mechanical energy is given by. Finally, we find the equation which rules the world, 9. With my equation, we can predict the behavior of a quantum particle in a well of infinite or finite potential.
In conclusion, we can say that solar energy is an alternative to fossil fuels. Nowadays, multiple kinds of photovoltaic cells already exist. Monojunction cells in silicon, mono and polycrystalline, and cells with thin layers. But it's important to find more efficient products. Some systems will combine photovoltaic with thermal solar, with the advantage that the thermal solar part carries heat away and cools the photovoltaic cells. Basically, the short-term goal is to improve the pre-existing technology. Then the medium-term objective is to develop industrially thin films technologies. And finally, the long-term goal is to discover new materials or new concepts.
Man, you need to help me. I have my jury tomorrow and I don't understand anything about photovoltaic panels. Can you help me?
Yeah, for sure, man.
Nice.
So don't worry, it's easy. First, sun emits light, which is constituted of photons. We then have seen that the semiconductors are able of transforming the light energy in electric energy.
Okay.
We then learn how the semiconductor behavior is typical to a p-n junction, so we were able to imitate our cell by a simple electric circuit. Afterwards, we searched to really understand why electrons in material can only take energies between some allowed strips, and we did it thanks to Schrödinger equation. Okay. This explains why it's thanks to these strips that proton can create current. Okay. So, does the solar panel still have any secret for you now?
No, I understand much better now. Thank you. Schrödinger is really a genius. Want to go for a drink?
Yeah, for sure. Let's go.
Yeah, for sure. Let's go.